Hi guys. Yeah, Lucas from zkML. I'm a founding partner. We heard a lot now about risk assessment and how to handle those risks in DeFi. When the question comes to how can I actually use those risk assessment models, when we're talking about machine learning on-chain, we are talking about zkML, zero knowledge machine learning. To start off, just a short introduction in both areas. So we're talking about zkML, zero knowledge machine learning. For that, we need to understand what is zk actually. zk fulfills two main promises. The one is privacy. I can use zero knowledge technology to prove you that I have a certain information without revealing the information to you. Sounds like magic, right? So how do I do that? I use zero knowledge technology. I compute a so-called zero knowledge proof with my private information. I hand over this zero knowledge proof to you, and you can run a verification method to check if I actually possess this information without getting any information about the secret. The second promise zero knowledge provides to us is verification. And we see this a lot in the recent months and years when we're talking about rollups, about scaling. Not really has anything to do with privacy. So people talking about zero knowledge proofs, but completely neglecting the privacy part. It's all about verification. We can actually offload computation from the Ethereum main layer to layers 2 and verify to the baseline computation was done correctly. And this is done via zero knowledge proof. For zkML, mainly the second part is important. We want to verify that a certain computation was done correctly. Closer. Okay.
Here is the.
Oh, got it. Thanks. On the other side, machine learning. Probably all of you heard about it. For us, two things are important. One is the deployment phase. So there is the training stage where I take the model, the raw model, I put in training data, I train my model. The second one is the inference. So I have my trained model, which is ready to use, and I actually put it into production. I put it live. For example, when you're using ChatGPT, you're typing some prompt and sending to OpenAI. That is the model inference. You're using their trained model to get some output. For zkML, we're mainly talking about the inference stage. It's not about training, it's all about getting verification of the inference. Other important part is the architecture and like the model itself, which consists of the architecture. So which layers does the model actually consist of? How deep is the model? How the nodes in the models are set? And the weights. The weights of the model is kind of the result of our training stage. So we put in data in the raw model, we get a trained model where those specific weights are set. So combining those two concepts, we get zkML, which is essentially a zero knowledge proof that a machine learning model inference took place. So you may now ask, why is it important for me? Why is it important for DeFi? When we look at TradFi, we see TradFi is kind of powered by AI. And that's not a new thing, that's already there. There was a survey conducted last year before this entire generative AI hype, which impact AI already had to TradFi business. And nearly or more than 30% say, yeah, we do substantially more revenue through AI, or we can substantially reduce our costs through AI. So that's not a kind of a future thing, that's already here. And the thing is, DeFi cannot really leverage on this potential so far. Before I joined the CEO, I was also running my own DeFi protocol. And for us, the entire ML part was not even a solution space we considered, right? So we were like, okay, we build our smart contracts, we build our investment strategies, but we were not aware that there is something like machine learning we can make use of in our smart contracts. Why is that? Because it's just unfeasible to run machine learning on-chain. Machine learning inference is super computational heavy, right? You cannot really put it on-chain because you're running out of gas, it's too expensive. That's not what Ethereum or any blockchain is designed for. The solution is we can make use of zkML. How does it work? We take our model, we do the inference of the machine learning model off-chain. So we save a lot of gas, we are not limited by the blockchain, but it's not just the inference we're doing off-chain, we're also computing a zero-knowledge proof of that inference. And what we put back on-chain is kind of the result of the model inference, plus the zero-knowledge proof that anyone else can verify that our computation was done correctly. So what we get is a machine learning enhanced smart contracts. Any smart contract can now make use of this technology to run machine learning models. Like one very specific example where we already see this, that this technology is used in DeFi is Ion protocol. Ion is a lending platform which essentially makes use of staked asset. So you stake your ETH, you take your liquid staked ETH to Ion, put it in there as a collateral and take out a loan, right? What Ion is now improving is kind of the capital efficiency. So based on the asset which is provided as collateral, they have a certain risk scores. Those risk scores are actually computed by a machine learning model, and kind of to prove to their users, to prove to their partners, stakeholders in the network, they also provide a zero-knowledge proof about the computation. So when I see staked ETH has a credit score of 5, I can be kind of sure that this is a random number set by one developer of Ion protocol, but that's actually the outcome of that one specific machine learning model. We have a lot of talks currently with DeFi protocols, with other Web3 players to figure out if zkML makes sense for them, right? So there are two basic questions we always try to answer in that process. Number one is using ML in your protocol actually gives you some tangible benefits? Or is it just a buzzword and you need it for a next fundraise? Maybe also fine, but you should really use it when you see, okay, when I use ML, I can get more yield, I can reduce the risk, I can be more capital efficient, whatever. But it should really give you some enhancement compared to your competitors. Second question, is the output of the model inference actually changing some on-chain state? What does it mean? So going back to our ChatGPT example, when I send some prompt to ChatGPT, you get a response. The response is not really automated, an automated input for another smart contract, right? So I just get the response and see, okay, I like that one, or I don't like that one. Maybe I rerun my prompt to ChatGPT, but it's not an automated process which changes some on-chain state. But another example would be I run a machine learning model to adapt certain parameters of my protocol automatically. Then the kind of the verification is very important, because otherwise you cannot really be sure that the set parameter is really coming from this machine learning model inference. So if you kind of can answer both questions with yes, maybe zkML is really important for you. I would like to guide you through the steps you could take when you want to integrate zkML into your DApp, into your protocol. So you start off by a trained model, right? So usually, as we said before, this is done off-chain. Second step is you need to convert this model in a so-called ONNX format. ONNX is a standardized format for, I don't know, maybe 99% out of all machine learning models out there are able to convert to this ONNX format. And we take this as an input to get down to this, like get from the machine learning environment to the zero knowledge environment. And this is done with, in our case, with a compiler we are building together with NIL Foundation, to get from the machine learning model down to the zero-knowledge circuit. The circuit is more or less a representation of your model in arithmetic gates. So a lot of plus, a lot of multipliers, but it's the same, but in a different representation form. Then you have your zk circuit. You can submit this one to the proof market. The proof market is kind of a matchmaker between you as a requester. I want to have this zero-knowledge proof computed, and some service providers, some infrastructure providers which are running dedicated hardware which can compute the zero-knowledge proof for you. So you kind of outsource the computation to the proof market. Then the actual proof generation takes place, and last but not least, you can verify the proof generation. And one important thing to the verification part, it could be extremely hard to compute the zero-knowledge proof, to run the machine learning model. Really, a lot of resources are needed, but it's kind of easy to do the verification. So maybe think of Sudoku. It's kind of hard to solve Sudoku, but super easy to check if the result is actually correct. It's a similar concept here. So one kind of technical overview, but I will walk you through, no worries. Let's say a very specific example. You as a data provider offer some lending platform, right? Right now it's kind of really capital inefficient because what we heard before, you need to over-collateralize heavily your position. So let's say by offering a service of credit scoring, we can bring down the over-collateralization rate and be more capital efficient. For that, the user somehow needs to get a credit score, right? So what's happening is you kind of get a lot of data, on-chain data, maybe KYC data. You're going to process this, and based on that, you're going to compute the credit score. You can do this manually, but it's kind of a cumbersome process, right? A lot of stuff needs to be processed. Or you kind of replace this process by a machine learning model. And here zkML starts kicking in. So the user is coming to your website, wants to say, hi, I want to take out a loan. Please compute my credit score. So for that, we need machine learning, and for that, we need zkML. So we're starting out by requesting a proof. We are sending down this proof to the so-called proof market, where the matchmaking between the supply and demand happens. So by some market economics, one proofer is chosen, which is then taking your circuit, like the kind of the code, how to compute the zero-knowledge proof, and the input, like this very specific function you want to have computed. The proof generator is then generating the proof, is sending everything back, like the credit score, which is the outcome of the machine learning model, plus the zero-knowledge proof, which then can be verified on-chain. And so you have kind of used machine learning via an off-chain computation via the proof market. So last but not least, some questions you should be prepared for, or you might get asked when you are discussing a zero-knowledge machine learning use case with teams like us. What's very important is to be aware of how your model actually is built, how it's set up. So how does the architecture look like? What's the framework used to create this model? Secondly, is it a static model? So do you have it once, or do you iterate on it? So it's changing kind of dynamically. Another question regarding privacy are the model weights you have. Like you trained your model, you got your model weights. Are those model weights kind of confidential, or is it not that really important IP you got there? And the same is regarding the input data. When a user is using your service, is this input data kind of private? Or again, is it public information, not that sensitive? There are certainly a lot of more, but I think those are the most important questions to be aware of. Yeah, if you think about adding zero-knowledge machine learning to your application, to your protocol, just reach out to us. My colleague Lucas is also here, so I'm happy to chat afterwards. Thank you.